Hi, this is Chris Kraft. We're going to drill down into why and how to consolidate databases. This applies to on-prem as well as Exadata Cloud and Cloud at Customer. This talk brings together a wide range of topics, so let's get started. When we talk about consolidating databases, there are 5 factors to consider. Our primary goals are to reduce cost, simplify operations, and improve our security posture. At the same time, we need to ensure availability to the business, and we need to provide the right level of performance. Consolidating databases is a matter of balancing all 5 of these factors. Starting with cost, we're talking about the cost of either purchasing Exadata for on-site or a subscription to Exadata in the public cloud or on Exadata Cloud at Customer. Managing costs at this level means we need to right-size the compute and right-size the storage, choosing the proper balance of both. Of course, in cloud models, we can also manage the OCPU settings to match the workload demands. High capacity storage is right for the vast majority of needs, but for on-premises deployments, we can also deploy extreme flash storage or extend the storage. So choosing the right type of storage helps us manage costs. The high performance of Exadata also means we can run the same workload in a smaller footprint than with traditional compute plus storage architectures. When it comes to simplicity, Oracle's strategy is to provide a single converged database that meets many different needs. This strategy is important for consolidation because you simply cannot consolidate divergent technologies. It's much better to have one database that fits a wide variety of needs. Oracle Database can handle all types of workloads, including OLTP, analytics, Internet of Things, and microservices. Oracle Database can handle the structured or relational data, but Oracle is also a leader in unstructured data like JSON or the document database modeling approach. Having one database that meets all needs means that we can progress through standardization to consolidation and finally to business transformation. In short, simplicity means deploying one standard database that can meet all of your needs, one database and one platform that can handle any workload at any scale and meeting any availability need. Of course, we also achieve simplicity by providing the right level of isolation between databases. Databases are obviously isolated by physical location. Some customers also need administrative separation, like when an organization has multiple administrator teams. Security separation is often required for high security data, such as PII. Isolating for maintenance purposes is about versions, patches, and scheduling of maintenance. Isolating to reduce blast radius means we limit the scope of any failure impact. And finally, if you simply need to manage noisy neighbors, resource management is the best solution. It's important to use all the tools available for isolating rather than just relying on one of them, like using virtual machines to meet all isolation needs. Okay, using the full range of tools at our disposal allows us to meet all the isolation needs in the most rational way. We can isolate databases onto separate physical servers within Exadata. We can isolate databases using virtual machines. Of course, we can put many databases onto a single server or VM and use separate Oracle homes, which means separate copies of the Oracle software stack. The highest consolidation density is Oracle multi-tenant, where we can manage tens or even hundreds of Oracle databases as a single container. Finally, if you just need to control noisy neighbors, the best choice is to use Oracle Resource Manager to isolate system resources like CPU and I/O. Okay, moving on to security, it's safe to say that security is critical to any organization. The combination of Oracle Database running on Exadata gives you the most secure platform available. The Oracle Database is known for being the most secure possible, and Exadata includes a number of security innovations that work in tandem with the Oracle Database. Exadata provides a minimal attack surface, and Oracle constantly scans the stack we ship for vulnerabilities and works to improve our security scores with each release. Other platforms and cloud vendors don't provide fully integrated security for Oracle Database. As the supplier of Oracle Database, only Oracle can do that, and we do it with Exadata. Okay. So the fourth major point we need to consider is availability. And it's important to know that Exadata can be used in all of the maximum availability architecture or MAA configurations, including bronze, silver, gold, and platinum. In fact, many of the innovations included in Exadata are driven by availability. One example of this is the speed of cluster reconfiguration on Exadata in the event of a failure. Reconfig happens in milliseconds on Exadata, but can run into minutes on other platforms. One major recommendation we have for availability is that customers need to implement application continuity. Oracle Replication Clusters enables rolling upgrades and fault tolerance. RAC is an active-active clustering solution that allows a database to keep running during failures or during maintenance, but applications need to have fault tolerance to match. Starting in Oracle 12c, application continuity effectively moved much of that complexity out of application code and into Oracle networking drivers, which makes adoption much simpler. Applications now just need to be configured properly to adopt application continuity by following a simple configuration checklist. Okay, so performance on Exadata is largely about allocation and management of system resources. We allocate resources at two levels in Exadata, starting with system shapes, as well as database resource shapes. For the system shape, you determine the volume of storage, amount of compute capacity, virtual machine sizes, and number of nodes in each cluster. We then recommend allocating resources to databases using standardized resource shapes. These standardized shapes use equal proportion of resources, meaning if a database needs like 10% of CPU, it should also get 10% of memory, 10% of processes, and 10% of I/O. These shapes can also flex a bit using minimum size shares as well as limits on the upper bound. The methodology outlined here is explained in more detail in our best practices paper on database consolidation. Okay, so for a final point on performance, it's important to remember that Exadata is a fundamentally different architecture. We talk about the fast components inside of Exadata, like the 100 gigabit internal network, 16 million IOPS in less than 19 microseconds IO response time. Those numbers are much faster than anything else on the market, but it all works much differently than traditional systems. Exadata is really unlike other platforms. It's not just compute plus storage. It's not just fast components. Exadata offloads work from the database into the storage instead of moving the data into the servers. Yes, that includes SQL offloading, but also other functions of the database like cluster interconnect communication and redo log handling. One example is how the database on Exadata uses RDMA, or remote direct memory access, to access data in Intel Optane persistent memory inside the storage layer. Again, you run the same Oracle database on Exadata, but it operates in a much different way internally. The best way to explain this is that Exadata is database-aware storage. Exadata does things like prioritize I/O in a way that's database-aware. Exadata also considers the timing of those I/O operations and how that timing relates to the state of transactions in the database. It's not just the object that's important, but when it's important based on what's happening in the database at any given moment. The database transaction log is important, but it's even more important during commit. Writing database blocks tends to be less important, except during a checkpoint. Exadata is designed specifically for running Oracle databases and takes these factors into account. So this level of integration makes it much faster than other platforms. To wrap up this discussion, we come back to the 5 factors of cost, simplicity, security, availability, and performance. It's important to balance all 5 of these factors when consolidating, and that's true whether you're consolidating databases on-prem or in the cloud. Let me leave you with some references related to this presentation, which are the database consolidation best practices paper, as well as the application continuity checklist. You will find both of these among the content in the virtual resource section.